Alright, so this problem is about going to the supermarket, and you might want to know this if you're a marketer or researcher. It's helpful to know how long will people be inside of my store, because you might change your marketing strategies based on that information. So that's kind of what this is about. It says a survey shows that each shopper in a supermarket spends an average of 45 minutes, so that means mu is 45, and the deviation, the sigma, is equal to 12 minutes. Okay, length of time is normally distributed, so obviously, normally distributed means that most people spend some average amount of time in the store. These are people that are like in there for 2 seconds to buy a newspaper, and these are people that are in there for like 3 hours chatting with their friends in the aisle or something. So those are the extreme cases, but most people have some average time, and it looks like 45 minutes is the average. Okay. Lengths of time are normally distributed, represented by the variable x, and we want to know the probabilities for each of these intervals. And then this is important: interpret this when 200 shoppers enter the store. Okay, so we'll talk about that part in a sec. Let's start with this: between 24 and 54 minutes. So 24 maybe is roughly right there, and 54 is roughly right there. And we are being asked to find the area between 24 and 54, because that's probability. Remember, area and probability mean the same thing. So let's go to normal CDF, and we will put in our lower boundary, which will be 24. Our upper boundary is going to be 54. Remember, we don't want to put 0 and 1 for these anymore, because that's when we're using z-scores. If we were using z-scores, that wouldn't be a 45, that would be a 0. But for now, we're not using z-scores, so I'm going to put the average time there. And remember, our sigma is 12, so that's going to be sigma right there. So let's plug those into our calculator, which I'm doing along with you off screen. So 24 comma 54 comma 45 comma 12. Okay, and I'm saying commas, I'm using an 83. You might be using an 84 instead. Okay, and I'm coming up with a number of 73.33%, 0.73, but I'm obviously changing it to percent. So there's a 73% chance. I'm going to use a different color for this one, more than 39. So 39 might be right here, and we want to know the green area, and it looks like it's definitely going to be more than 50%. Okay, just like the other one. So normal CDF, our lower boundary is going to be 39 this time. Our upper boundary, when it says more than, that means area to the right. So our upper boundary is going forever in that direction to infinity. I'm going to use 10,000 instead of infinity, because we don't have an infinity key on the calculator. And these are still going to be 45 and 12. So let's calculate that, and when we do, which I am also typing in along with you right now, 10,000 and then comma 45 comma 12. When we do that, I'm getting, it looks like 69.15% chance, okay, that will happen. So now let's finish this problem. It says interpret this when 200 shoppers enter the store. How many would be expected to be an inch interval? Well, for this one, 73% of shoppers are going to be between 24 and 54. So if there are 200 people in the store, then I need to know what is 73% of 200. That's the multiplication I have to do, and it turns out to be about 147. I would round up, because you don't want to have, it's actually 146.66. Well, we don't want to have 0.66 of a person. That would be pretty awful. Okay, 147 is much more humane answer. And then right here, 69% of 200 is going to be 138.3. So let's round to 130. I mean, it really doesn't matter. You could round to 138 also. But out of 200 shoppers, we would expect 139 of them to be more than 39 minutes. Okay, so that's how we can apply that to a real life scenario.